Well, appreciate everyone joining us this afternoon. This is Kerry Dissinger with Jim Myers & Sons, and for the next 20 minutes we're going to go through our bearing developments with the Mega-bearing, high-performance bearing system. So the first slide you're looking at here shows an assembly of a full Mega-bearing system. So you see the cast stainless steel housing, the 17.4 pH stainless steel shafting, a mega coupling, which is used for misalignment. You see a bearing base plate assembly below the bearing. Those are the main components that make up this mega bearing system. And we'll kind of just walk through what some of these features do for us in the market. So here you see an exploded view of the different components that this system's made up of. So it's made up of a stainless steel basically for corrosion resistance. Most all of the jobs that we're doing today and for the last decade, pretty much all of the equipment is stainless steel, especially in the wetted components in the basin. I mentioned the cast stainless steel housing for high strength, the leveling plate below the actual bearing that allows the contractors to install in a level fashion and have better alignment for all of their shaft installation. The dual disc coupling, again, that is for misalignment and differential wear throughout the life of the system. The new HPVT liner, so that's an NSF 61 certified liner that typically lasts 10 to 15 times longer than a PE liner. 17.4 shafting at the solid shaft through the liner, and that is a hardened stainless steel which is twice as hard as 304 or 316 and twice as strong. In addition to that, we have manufacturing enhancements. So we have a 30-foot lathe where we face all of these shafts to within 1/10,000th of a parallel facing operation. Bearing wear issues, and all of these items we've basically learned kind of over the last 55 years doing horizontal paddle wheel flocculators, and what we found is bearing liner wear has always been an issue for this style equipment, and developing a bearing liner that would last much longer is really what the market needed and what the industry was really looking for us to solve. So some of the issues you see with liner wear issues is misalignment, shaft breakage, scoring of the shaft, or even bearing failure. And that results in basically a lot of time and money for the plant with idle sections of the basin, lower performance, downtimes, and repairs. So that's really, when you look at this little liner here, that's kind of the key to horizontal flocks, and having those last as long as possible is key. This just shows you some pictures of older technologies that have been in the industry for a long time. So the upper left, you see a corroded shaft. And back in the day, what they would do is they would do painted carbon steel with all solid shafting and compression couplings. And we're just kind of showing you that to see that we've really come a long way since that style flocculator. The scored shaft in the upper right, that just shows what can happen to shafting in traditional liners. Like a PE liner is relatively soft, and therefore that liner will pick up sand and grit, and it can actually act like a sandpaper in scoring the shaft, especially if it's a normal stainless steel shaft or even a carbon steel shaft. And that's a reason we do the hardened stainless steel, is to eliminate the scored shaft and basically replacing that in a timely fashion. Bottom left corner, broken shaft. So this happens when you have misalignment, and that can be due to bearing liner wear. It can be due to not facing the flanges when you bolt these together. Really, we've replaced a lot of competitors' equipment over the years, kind of all across North America, because of our manufacturing processes are superior to those that kind of make flocculators and really haven't advanced the technology. So just showing you a couple items here of some of the older technologies. Every one of these items has been addressed with our mega bearing system. The cast housing, that's kind of the heart of the system. So you have a base and you have a cap. Again, it's a cast stainless steel. So when I say cast, it's actually a sand casting process. Let me just kind of show you the actual process here. So we have actually invested in the molds, and we pour and cast all of those housings to have a raw stainless steel casting. From there, it goes through an extensive machining process. But the casting process is really where we start, and really what's unique about that is that we've put the investment and the design time into having our own cast stainless steel molds. This slide shows you kind of a raw casting, what it looks like, and then to the right of that you see a partially machined casting as it's going through its process. So you can see we have to face the surfaces, so you have a parallel spacing, and then also there is a key to stop the bearing from rotating. You can see there's holes put in this for attaching the cap to the base. The bottom picture shows a machined base, so the first thing we do is machine the bottom of that casting, and we make sure those faces are parallel to one another because alignment of the entire flock shaft system is very, very critical. So this machining operation is very key to having a high quality bearing. And here you can kind of see the first step of the process. So here they're machining the base and then the top of the base, and the reason they're doing that and where they start with that is that sets the parallelism between all of the bearings and their caps, and it's highly important to get that first part to a very, very high tolerance. The new Polytex HPBT liner. So I kind of mentioned this earlier, so this is really critical, and we've actually worked with a local expert in the plain bearing industry. So when we say plain bearing, we mean a friction style bearing or journal bearing. So it's where it's non-lubricated, or in this scenario it's basically water lubricated because it's underwater, but we're not adding any grease to this system. So it's water lubricated, fully submerged, and here I'm just going to kind of go through and kind of show you the different liners and what they look like. So these are some mega bearings that were done for a project down in Dallas, Texas at the Eastside Water Treatment Plant, which is one of the larger water treatment plants in the country. And they went with all cast stainless steel mega bearings at that installation. These two options you see here have a PE liner and a bronze liner, so kind of the older technologies, but since then we've basically exclusively went to the HPBT liner. And here you can just see the different look between the two. The right is the PE, the left is the HPBT. And just some of the reasons why we use that: it has a much higher PV ratio, it's much harder, so you don't have any issues with plastic creep over time under load, because even though the flocculators are moving slowly, typically 5 RPMs or plus or minus in that zone, they're relatively heavy, so you have a lot of weight acting on the bearing, and a traditional PE liner does not do well in that scenario. But when you look at the HPBT, it's a much harder liner, so it stands up well to the weight of the system. Again, I mentioned that it was NSF 61 certified, and you can look for life up to 15 times longer. So that's really one of the biggest keys and why this liner has been selling across the country, very, very well. Because the most feedback I've received from the plant has been around maintenance issues and maintenance concerns, and they're always asking, how much downtime will we have? How much maintenance do we need to do? Because like we all know, plants nowadays are relatively short-staffed when it comes to, maintenance personnel. So any downtime in maintenance is kind of difficult and very time-consuming and, costly. Into the next component. So this 17.4 pH stainless steel shaft rides in the HPBT liner, and it connects the pipe shafting for all of the reels of the paddle style flocculator. So all of the torque goes through this solid shaft. And like I said, we do a hardened stainless steel, which is a 17.4 pH, so it's precipitated hardened, twice as strong as 304 and 316, and twice as in the hardness scale. And that's really the big factor that we're looking at is in the Burnell hardness. It's twice as hard as the other components or other raw materials such as 304, 316, or carbon steel. The mega coupling, this is used for misalignment, and this is a very critical component when you're working with horizontal paddle wheel flocks, especially on larger systems. The job I mentioned to you down in Dallas, Texas, that is one of the larger plants in the country, and you have on one stage there are 10 reels. So it's very, very long, and misalignment can be an issue in really large basins like that. even so much so that it might be aligned when the basin's empty and you shoot it with a laser and you get all of your alignments there, but when you fill it with a couple million gallons of water, they can actually have settling of that concrete, which causes some misalignment. And the mega coupling is designed to take up that misalignment so you don't have any premature breakage of the shafts. You can kind of just see an exploded view. So it's made, so the flexible discs are what give it its misalignment capabilities and characteristics. So you kind of see there's two sections there. That's what we call it a dual disc coupling, and that gives you the misalignment characteristics that you need for this type application. This is a project spotlight in Oakland, California. So at both of these plants, at the Sobrante plant and the Upper San Leandro, they installed stainless steel mega bearings along with the HPVT liners. The reason they went with that is the water characteristics coming into that plant are very hard on painted carbon steels and very, very hard on bearing liners. They were replacing their bearing liners, every 6 months to a year before they installed our mega bearings with the HPVT liner. Since then, every year they go in and they basically will mic and kind of see how much wear the bearing had, and they report back and kind of give us that data. And over the years when we were kind of looking at that data, that's where we came up and kind of back calculated they're going to have a 15-time longer life expectancies versus the PE or even the aluminum bronze liners that they used prior. So for that plant, that's been a huge success story, because really they didn't want to be replacing bearings once a year. Sometimes this plant they couldn't even take down depending on demand. But I would definitely talk to the owners and the operators, because that's really, when we talk to them, it's kind of a no-brainer, because a lot of times what we see is people have always liked the horizontal flocks. They've produced a very, very high-quality flock particle, but 30 years ago, it was all carbon steel. So fast forward to today, they're pretty much all at the end of their useful life, and they kind of look ugly, corroded, and they just start getting to a realm where they're a nuisance because they're at the end of their useful life. But once we get in front of them and can kind of walk through all of these different improvements that we've made, it really becomes a no-brainer for them. And really, every time we've done this presentation to the owners, they're like, well, that's what we need, because we don't have maintenance guys like we had 20 years ago. We can't be taking these basins down, and we got to rely on this basin uptime. Like, we need it running 99% of the time is really what we hear all the time. All of JMS's mega treatment equipment, which is used in the drinking water industry, is 100% NSF certified, to include down to the actual liner itself and the bearing assembly. So that's unique to JMS. I'm not aware of any other manufacturers that have that level of safety regarding the quality of the equipment going into the drinking water. So that's kind of my quick version of the PowerPoint, and I'll kind of show you a couple areas where you can see a little bit more info on this. And just a quick reminder, but if you go to our website and kind of just scroll down through the top version here, you'll kind of see pictures of the bearings, kind of what you can expect them to look like in the field. But when you scroll down, you'll kind of get some of the high points. You kind of see the NSF 61 certification. It will talk about the different components I just went through, and kind of just a good refresher to kind of look at what all features this bearing has. And really, the features are the result of solving real-life issues that the plants were experiencing, and that's really the value of this system, is solving real-life situations and making things better by reducing maintenance and having the equipment. The last item I'm going to show you on our website, if you click on the Learning Center, and that will take you to the Learning Center here. And this is a place that we'll probably even post this real quick webinar on there, so other people can kind of view it at their leisure and kind of listen to it. But as you scroll through here, you'll kind of see information about the NSF 61 certification, and you can find more information out about our products located here. You're kind of asking about the different components that make up the actual system. Yes, so primarily we like to always have the cast stainless steel HPVT and the 17.4 liner. You don't always need a mega coupling. We have a bunch of smaller projects right now in Colorado, and they're either like 1 reel or 2 reels. There's very little chance for misalignment in those type installations, so on those, a lot of times we don't recommend that style for those small installations. No, we do quite a few retrofits. That kind of falls into our aftermarket parts division. The gentleman that covers that, his name is Troy Reeves, but every day he's supplying stainless steel bearing housings and HPVT liners for retrofits across the country. So this has been named on a lot of projects, and we've had competitors bid into it. So they have some level of solutions for that. I'm not 100% sure what they're doing. One in particular where we got to be careful, though, is to make sure that sometimes when this gets specified, competitors could kind of ignore it and try to bid something that would not be to the quality of this stainless steel housing and all that. There are ways for the competitors to get these housings. They just won't have them in-house like we do, so they have to kind of buy them out. So it can still be bid in a competitive environment, but just got to be careful that they're truly bidding to these features. And the reason I mentioned that, there was a large job in California that this was specified. We talked to the owner, the engineer, for about a year, and it's really the system that they wanted because they had a lot of issues over the last 2 decades with their horizontal flock system. And when that bid, we ended up losing that by a little bit, but 6 months later we got a call from the contractor that was installing the competitor's equipment, and he sent us a bunch of pictures and all of that, and when we saw what the competitor actually provided and was calling an equivalent stainless steel bearing, it was very disturbing. It was basically a block of PE, and on top of the block of PE they had a 1/4-inch plate, and then they kind of had 4 long bolts through that down to the base plate, and that plant was having all kinds of issues with misalignment. The reason is when you have a large, thick piece of PE, and then you have it sitting in the sun, and you have several thousand pounds kind of acting on that PE, it was constantly moving, and they had issues with shaft failures and stuff like that. So I just kind of caution you regarding the or equals. There are ways for them to get the actual housing itself. That's the most critical component that's going to be there really forever, and that's what you need to, when you look at this picture on your screen now, you see a large jack bolt. The alignment of that and keeping that aligned is very, very critical. So say in 5 years we got to go back out and replace the HPVT liners. You never really need to realign that as long as that base stays aligned. So the base being as robust as it is and the way it's designed is a lot to do with alignment and long-term alignment, because really no plants replace bearings and then do a laser alignment. That's kind of done during installation, and once those bases are set, it's kind of a done deal. You can see they're grouted into place. I appreciate all the questions and appreciate everyone taking the time to join us today. So with that said, just to kind of be on time here with our schedule, we're going to conclude the presentation, and we appreciate it, and join us on the next one. Thank you very much.